Hi, today's lesson is 3.6 special segments in triangles. And the objective is how do we identify and use special segments to solve problems. So we're going to be encountering 4 different types of special segments and we're going to learn and identify them in the triangles and know how we're going to apply them and use it. All right, the first one is perpendicular bisector. The definition for it is a line, a segment, or array that passes through the midpoint of the side of the triangle and is perpendicular to that side. So it's coming from the side, and then it passes through the midpoint. So I have a little diagram that shows what a perpendicular bisector. Basically, it cuts through a segment, a line, whatever it is, and it creates two congruent segments, and of course the lines are perpendicular. The properties of a perpendicular bisector will result in midpoint. You'll have a midpoint. When the midpoint, there's be 2 congruent segments and perpendicular lines, which will give you right angles. So a point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So equidistant means equal distance. So make sure I have, okay. So we have a picture here, a diagram of a segment, and a perpendicular bisector is cutting right through it. So what happens is that you get a right angle, as seen as in this symbol, and then you get 2 congruent segments, AC and BC. And if you were to put a point, which I've done, point R, on the perpendicular bisector and draw a line to the ends of each of the segment, to each end of the line segment, then those lines, which is RA and RB, will also be congruent. And the 2 lines that are connecting at point A and point B will create an angle, and they will both be congruent. So as you can see from below, we got segment AC is congruent to CB, segment AR is congruent to RB, and angle RAC, or angle A, is congruent to angle RBC, or angle B. So basically, with a perpendicular bisector, it creates 2 congruent segments. It will also create a right angle. So we're just going to do an example based on the perpendicular bisector. They're asking us to draw one of AB in each, draw a perpendicular bisector of AB in each triangle below. So I'm going to get my line, and I'm going to draw a perpendicular bisector. So from this point, so I'm going to find where the midpoint is. So it would be the middle, I'll say right here. And then my perpendicular bisector will go straight this way. So that means those 2 lines, AB, and I'm just going to make this C and D, is going to be perpendicular to AB. So CD will be perpendicular to AB. And I'm just going to write that here. AB perpendicular to CD. Segments, actually put ray CD. So that means AD is congruent to BD. So those 2 segments will be congruent to each other because of the perpendicular bisector. Now I'm going to draw another one on the other triangle. I'm going to use my line. Find the midpoint. I'll say right here, and you just draw it straight up. And I'm going to label. I'm going to use another color. So this will be, I'll make this F, and then this will be, I'll make it E. So now this will be perpendicular. So that means AB is going to be perpendicular to EF. I'm going to make that the ray EF. And that means these two segments, AF, is going to be congruent to BF. So that's all you do with perpendicular bisector. You start at the midpoint of a line, you go straight up, and then you create two congruent segments, and the two lines, that perpendicular bisector and the line that you started off from, will be perpendicular. So we're going to apply this special segment to a problem. It says that GI is a perpendicular bisector of FE. So FE is right here, and we got GI, so that means this GE and GF are congruent. So I'm going to write that here. So what I'm doing is I'm writing all the information, whatever they've given me, and then find whatever I found from what the information that they gave me. I'm writing it down so I've got something to reference from. So I know these two are going to be equal, congruent. And then they said EH is 16, and then FH is 6x minus 5. All right, so remember from that diagram before, so I'm just going to go back. This little diagram, you have the perpendicular bisector, you created two congruent segments, and if you choose a point from that perpendicular bisector and connect it to the endpoints of that segment, then they're also going to be equal, congruent. So that means this part is congruent to this part. So they're equal to each other, so you set them equal to each other because of the perpendicular bisector. So once you do that, then you just solve. So I'm going to leave that 6x there, and then I'm going to add that to the other side. Make sure I had everything correct. Yeah. And then I divide 6 on both sides, and then my x is going to be, just get whatever decimal I get with that one, 3.5. And that's it. So anytime you have a perpendicular bisector, you start from the midpoint, go straight up, vertical. It's going to create two congruent segments, and whatever point on that perpendicular bisector you choose, and you connect it to that segment that you started off from, it will also be congruent. Right. And there's another example where we have DE as the perpendicular bisector of AC. So that means this is congruent, AE is congruent to EC. I'm just going to write that. AE, segment AE is congruent to segment CE. So that means those two are equal to each other. You just set them equal to each other, the two expressions. So then this would become negative x, and then you add 2 on both sides, you get negative 7. So x equals 7. And that's all they're asking you, to solve for x. Right. The second special segment is angle bisector. You should already know this. We've encountered this before. Angle bisector is a line, segment, or ray that passes through the vertex of an angle and cuts that angle in half. See that word bisector? You cut it in half. And make sure you distinguish between perpendicular bisector and angle bisector. Angle bisector means you're just cutting that angle into two congruent angles. So as you can see in this diagram, we have a full angle ABC, and then BP is the angle bisector, and thus it's creating two congruent angles. You got angle ABP and angle CBP. They're congruent to each other, so that means they're equal. So the properties of an angle bisector result in two congruent angles, not two congruent sides. Because you hear the word angle bisector, you're cutting the angle into two congruent angles, not sides. A point on that angle bisector is equal distance to the point on the sides of the angle formed by the perpendicular line. So you have this angle bisector, which is OL, I should say LO, and that means, I'm going to mark it up with green. So this is the angle bisector, and then this is congruent to this angle. And if you were to create, see K, where K and M are, if you create a line perpendicular to the ray, it's going to be, you have that little marker that tells you perpendicular. When it hits that point on the angle bisector, then it's going to be equal. These lines, this one is going to be equal to this one, congruent to that line. So I'm just going to write that KP, segment KP is congruent to segment MP. So this works when you have a line from that ray, I should say, yeah, the ray from that angle. So when you have the full angle, and let's say you create a perpendicular line that intersects with the angle bisector and it's perpendicular, and you do it on the other side too, then it's going to be congruent. The angle is going to be congruent, and then that's going to be congruent. All right, so for this one, we're just going to draw the angle bisector of angle C. So I take my line. So I'm going to start here. That's the vertex. That's where the angle bisector begins, at the vertex of the triangle. And then you just draw the line. So that means once you do that, those two angles will be congruent. So try to eyeball it and make the angles congruent. So these two are going to be congruent. So I'm going to put angle BC, and I have to put this D. Angle BCD is congruent to angle ACD. And notice, just FYI, notice that I don't say, when I said angle ABCD is congruent to ACD, I didn't say DCB. Because when you have congruency, whatever it is on one side, it's going to be the same on the other side. So if you started at this point, then you have to start on the opposite side, the same location, but opposite. So that's why I said that BCD is congruent to ACD. Because it's almost like if you fold it, and that point where they line up, that's where you would start. And then for the other one, I'm going to do the line and start at C. And then this is my angle bisector. So I'm not going to make it perpendicular, because it's not a perpendicular bisector, and it wouldn't start at the vertex. So I'm going to my goal is to make the two angles congruent. So I'm just eyeballing it to make it look congruent. So then this angle and that angle will be congruent. I'll make this E, and then I could say that angle ACE is congruent to angle BCE. And that's it for that one. So we're going to do practice problems that's dealing with the angle bisector. It says find X and and EF. So X and EF if BD, segment BD, is an angle bisector. So this is the angle bisector. So that means this angle is congruent to this angle. And notice how we have this line that is perpendicular to the side of the angle, and it hits the angle bisector. So that means that this line is congruent to, this segment is congruent to that other segment. So I'm going to write that the segment GF is congruent to segment EF. And also, angle CBD is congruent to angle ABD. Alright, so now I know that these two are congruent to each other, I can set them equal to each other. So 2x plus 6 equals 4x minus 1. do the work. This will be -2 on this side, and this will be -7. Yep, -7. And then I just divide 2 on both sides. I'm going to end up with a positive number, and that positive number is going to be 3.5. Alright, so I found x. I'm not done yet because they asked me for two things, to find x and EF. So I look for EF. So EF is 4x minus 1. So I'm going to plug in what I found for x. So I'm going to put this so that way you know where this is coming from. And then I just plug in my 3.5 and I'm going to put that in blue. And then I'm going to solve. So we got 4 times 3.5, which gives us 14, minus 1. And then EF is equal to 13. So I found the two unknowns that they were asking us for. Alright. So move on. For this one, the same thing. They're saying that MR is the angle bisector of NMP. Angle 1 is 5x plus 8, and angle 2 is 8x minus 16. Solve for x. This one, they're congruent. So again, you set them equal to each other because angle bisectors create two congruent angles. So this would be -3x, and then this would be -24. You just do the work, and then you will get x as 8. Alright, that was it with that. Now let's move on to the next special segment. Median. So the definition of median, so let me go back to select, is a segment whose endpoints are on the vertex of a triangle and the midpoint on the side of the and the midpoint of the side opposite the vertex. So you have the median. That median is the middle of the base of the triangle, and then it goes to the vertex. So we're going to show that in the next diagram. So I'm going to use my line. So basically, they want us to draw the median of AB in each triangle. So the median, you're starting at the vertex of the triangle, and then you go into the middle of the line opposite that angle. So for this one, we're at the middle. Put my dot here, and I'm going to put C. That was a very deformed C. Let's do that again. C, and then this will be D. So that means this will be congruent to this, and that's it. So we're going to put BC, segment BC is congruent to segment AC. Because the median means middle of the line that you're trying to, I would say, cut in half, make it in half. And you're starting from the vertex of the triangle. Same thing with the other triangle, which I will use another color for that. Actually, I'll use the line first. I start from here, and I go to the middle. I'll use green and label this. This will be E, and then this will be F. So that means this is congruent to that. So segment AF is congruent to segment BF. And that's it. Median just cuts the line in half. The only thing that's going to be congruent is the segment that you're trying to have equal, that you try to make equal. So that's all it is to median. So for the properties of median, it results in two congruent segments. That is all. And the three medians of a triangle, so you see the picture down here, you've got three medians. Basically, you start from the vertex and you end up in the middle of the segment opposite that angle. And you do that for the other sides. It's going to intersect at the centroid. The centroid is I'll show it with the purple, is here. This is what it's called, centroid. You would say center, but the mathematical correct term is called centroid. And that point P is the centroid of the triangle below. So when you have those three medians intersect in the triangle, because the triangle has three sides, and you have the three medians intersect at the center, that center is called a centroid. All right, so we're going to do a practice problem. For me, oops, I think I skipped something. No, I didn't. For median, we're going to do a practice problem. So it says find x and find EG. And find x if EG is the median of triangle DB. I'm messing up here. DEF. All right, so I'm going to choose green for this one. All right, so we know that this is the median. So that means this segment is going to be congruent to this segment. So if that's the case, and I'm going to write that, FG, segment FG is congruent to segment DG. So that means I'm going to set those two expressions equal to each other. So 5x minus 17 equals 3x plus 1. And then I just solve, subtract 3x on both sides, and then I add 17 on both sides, divide the 2, and then I'll have x equals 9. Simple. Okay, next one, same thing. In triangle PRS, TX is the median. So this one is the median, and I'm going to highlight that so that way you don't get confused with PT and assume that that's the median, because it's not. So this is the median, and with green, so that means this is going to be congruent to XR. So I'm going to write segment SX is congruent to segment RX. So now they said that find RS. So we need to find this whole base. So I'm going to put a big question mark. Find FRX if find RS if RX is 7x, 7 plus x, and SX is 3x minus 11. There's a lot of x's in here. All right, so we know that these two segments are congruent. So that means we're going to set them equal to each other. So I'm going to put 3x minus 11. That's for SX. And RX is 7x plus 7. All right, so then I solve. Subtract x on both sides, get 2x. Add 11 on both sides, so I get 18. I divide by 2. And then I'm going to get x equals 9. So I found x. That was my first thing, but now I have to find RS. So I'm going to change the color to green. And what I could do is, since they're both the same, they're both equal, I'm going to plug it into one of them. So 3x minus 11. Should have chose x plus 7. That would have been easier, but whatever. Plug in. And then just simplify. And then this would be 16. So that means that was for our SX. So this is 16. I know this is going to be the same. So that's also 16. So then 16 and 16 gives you 32. And I'm going to change that color. So 16 times 2 will give me, and I put segment RS or SR, same thing, will equal 32. All right, so that's how you would do it. Okay, the last segment, special segment you'll deal with is altitude. Altitude is the same thing as height. When someone says to you, what's the altitude? Especially when you're in an airplane, you're climbing a mountain, ask your altitude, that is referring to height. So definition is a segment from a vertex to the opposite side of the triangle perpendicular to that side. So remember with the median, we start at the vertex, but we go to the opposite side, but we try to find the middle of that segment. With altitude, we start at the vertex, but we just go straight down, which will make that line, that height, perpendicular to the opposite side. So with this one, I use line. I'm just basically starting from the vertex. So this is my vertex. Actually, I'll start with this one, C. Yeah. C, and just make a line perpendicular to AB. And I'm just going to label all my points that I need. So this would be D. This tells me, when you draw the little marker, it tells you that it's perpendicular. So then that means C, I'm going to put CD is perpendicular to segment AB. So that's it. It doesn't make it equal. There's no congruency. The angles are not congruent. All it does with altitude is just creates perpendicular lines with the base. For the other one, this one's a little trickier because this is where you need to start, but then you would need to go perpendicular. So I'm going to take that line, start from C, and you're just going to go straight down. Notice that it doesn't hit the base, but what you can do is you can extend the base of that triangle. So I'm extending it, and then I create my, I'll use the green again, and you create that perpendicular line. So I'm going to put my point here, which is D. And then you can see that, actually, I'll make it P, just to make it different from the other one. So that we see that CP is perpendicular to segment AP. So that's all. So when it comes to altitude, if you have a triangle like this that is tilted like this, all you have to do is start from the vertex of it and draw a line straight, just vertical, extend the base where the two lines meet. It will be perpendicular, and then you have what you need. You have your altitude. So the altitude can be inside the triangle, and it can also be outside. Right. So with the properties of altitude, it results in 90-degree angles or two right triangles. And with the two right triangles, it says like in the next unit, we'll do a full investigation dealing with triangles created by altitude. So that will be for the next time. But altitude is the height of a triangle, like I mentioned to you before. And there was a little star when we were talking about the definition about the opposite side. So it says so the altitude can be inside or outside the triangle. So it may not be the actual side, but instead it's the extension of that side. So going back to that diagram where we had the altitude and it was outside the triangle, and I said to you, extend the base so that the perpendicular line, the altitude, intersects with the base that is extended. So that's what that means. It can be inside or outside the triangle. Okay, so we're just going to do an example based on that. So it says that find x and ij if hk is the altitude of triangle hij. So this is the altitude, so that means this is 90 degrees. And now, if this is 90 degrees, you see this angle 3x plus 3? And there's a little degree sign, so that's an angle. So that means 3x plus 3 is going to equal 90 degrees. Because it's the angle that we're looking for, and we know that whatever this is has to equal 90. So we need to solve it. We're going to subtract 3 on both sides, so we get 87. And then we divide 3. And then for that one, our x is going to be, is going to be 29. So we found our x. That's the first thing we need to find. The next thing we need to find ij. That's the whole bottom of that triangle. So I'm going to use green, and all I need to do is plug in my x to each of them. So this one will be 29 plus 8, and then this one will be 29 minus 9. So I'm going to add these two, so that'll be 37 for this one, and then this one will be 20. So when I add those two, that will give me 57 for ij. For segment ij. And that's it. So basically you're just using what you know. Figure out what they're asking you for. Use what you know based on the special segments and then apply it. And then another one, altitude is PT. So again, when they tell you an information, mark up your drawing so that way you do not get confused with something else. And they say, what is the value of x if angle PTR is 8x minus 6? So this angle is 8x minus 6. We know that when you have an altitude and it goes straight down, it's going to create perpendicular lines, which is going to give you a 90-degree angle. So you know that this is 90. So we can set that equal to 90 degrees. And then we just solve. So 8x, we add 6 on both sides. And then we divide. And then we get 12 for our x. So that's all they wanted us to find. So x equals 12. Okay. So for this one, it says, for which, because we learned all the different types of triangles from the previous lessons, and with the special segments, they say for which type of triangles are all 4 special segments one in the same? So if you think about it, we learned about perpendicular bisector, we learned about angle bisector, median, and also the last one, the altitude. Altitude. So we're looking for a triangle or triangles that will have all those segments work out for it. And the 2 types are all equilateral triangles and isosceles triangles. If the special segment comes from the vertex angle, because remember, isosceles triangle, the 2 sides and the base angles are congruent. If you were to fold it, it would be equal on both sides. And of course, with equilateral triangle, it's equal sides, equal angles. So if you would apply the segments to all of them, then it would work out. So, for example, a perpendicular bisector, it would make one side equal to the other side, segment equal to the segment, angle equal to the other angle. Same thing with the isosceles. With the median, you're starting at the vertex and you go to the middle. But basically, since there are equal segments on both sides, it's all equal sides, then you're basically cutting that triangle in half with the median. Same thing with the perpendicular bisector. Same thing with the altitude. And also with the angle bisector, because let's say with the equilateral triangle, if your angle is 60, you make it at 30, you're actually going down the middle of that triangle, of the equilateral triangle. Same thing with the isosceles. So those 2 triangles will satisfy all those 4 special segments, all of them. But the other types that are not those, no. All right, so we reach the end, and I'm just going to do a recap. A quick recap, so I'm just flashing through this. So we learned about the different types of special segments. Perpendicular bisector basically is going to create 2 congruent segments and right angles. With angle bisector, you're starting from the angle, and it's going to give you 2 congruent angles, not sides. With the median, you're going to get 2 congruent segments, and then if you have the 3 medians intersect each other, you meet at the centroid. And with the altitude, same as height, you're going to get a 90-degree angle. That's all you're going to get. Or 2 right triangles, but because based on the line going straight down, you'll get 2 90-degree angles or 2 right triangles. And right triangles have a 90-degree angle in it. All right, so we've reached the end, and that is all for now. So see you next time. Bye.